Okay, and welcome to our next session at Redefine Tomorrow 2024. My name is Anwood. I'm blockchain technical lead at SCB10X. And today we are honored to have Adrian Brink, co-founder of Anoma, with us here. Adrian, thank you for being with us today. Uh,
Thank you
today
for
we'll
having
be
me.
discuss Today we'll be discussing about redefining dApp development with Anoma's intent-centric design and composable privacy. Quite a lengthy title, so I'm sure we have a lot to go through today. Thank you, Adrian. So to kick off the first question, maybe a brief overview first. Can you explain me what's the core idea behind Anoma?
Yeah, absolutely. The core idea behind Anoma is that everyone's interactions on blockchains are generally intent-centric. Generally, people have intents. They do not have transactions. They have a partial thing. They have, I want to get A for B, and someone else wants to get B for A. But I don't really care if I have A for B, who else, whether there's one other guy or multiple people that have the inverse or that have the thing in order to satisfy me. This is really the core idea that we are currently still living in this world that's very transaction-centric, even though most users and most applications are actually fully intent-centric. And here, there are other benefits of an intent-centric architecture, both on like intent level composability, intent machine composability, having heterogeneous trust models, things around composable privacy. But fundamentally, the idea of Anoma is it is the infrastructure for the applications that we're building right now that are lacking good infrastructure. Like really, like when you think of how we got to Ethereum, we got to Ethereum because we tried to build a bunch of things on Bitcoin and lacked good infrastructure for the things we were building on Bitcoin. And as a result, we got Ethereum and Ethereum-like systems. And this is the same with Anoma. Anoma sort of generalizes the infrastructure for the applications that we're currently trying to build on Ethereum, but are always ending clunky with central servers, whatever you have. And really here, Anoma is the first time that like it's a paradigm shift that we're moving away from transaction-centric world to the intent-centric world, where we can have an intent-centric and intent machine built on top of many different settlement layers.
Right. So you mentioned intent-centric versus transaction-centric, right? Can you elaborate a bit more, or maybe give an example of like what is intent and how is it different from transactions?
Yeah, so I'll start with the transaction, right? So transactions are very fundamental to virtual machines. Transactions are fully fledged state transitions. You can think of them as they can be directly executed against the system and update the system state. One good example of this is I go to a store and I buy some milk for some ETH. I have a transaction in this case because so the other side of the trade is I get physical milk in a store. In the intent-centric world, it's all about partial state transitions. It's I have the idea that I have some A for B, and I don't yet know who can provide me A for B. Some other person may have B for A, or maybe more complex. A second person has B for C, and then a third person has C for A, right? Like this is all about generalized state changes. But I generally, as a user with an intent-centric, and this is true for 99% of all use cases on blockchains at the moment, which is they're intent-centric. Users have partial things and they're trying to figure out with whom to coordinate with like counterparties that exist so that they can settle. And the second component to this is my intent may be settleable on many different systems, right? Like when you look at a rollup ecosystem on Ethereum, I may have an intent that I want to say, well, I'd be happy to trade on either Arbitrum or Optimism, give me whatever is the cheapest price. And intents allow you to abstract sort of the security model out of this because all of a sudden you just specify state changes, not compute. And in your state changes, you can define where do I want my state changes to happen? Do I want them to happen on Ethereum main chain? Do I want them to happen on Optimism? Do I want to have them happen on the Anoma main chain? Users can fundamentally decide where they want to have their partial transactions or partial state changes executed. And this is what an intent-centric model does.
Right. And I think I heard an analogy from before that, you can compare it to, say, hailing a taxi, where in the transaction-based world, you have to go to, you go out of your house and then have to hail a taxi, tell them where to go to, and you have to be like specific to that taxi, right? Uh, in the intent-centric world for ride hailing is that you have a ride hailing app like Uber or Grab in Asia, right? And then you can basically just tell where you want to go, right? But then the applications would actually allow that you don't have to care about which taxi you get, right? As long as you get to the place and you're paying this price, then you're satisfied, right? Is that analogy like accurate?
I would take this one step further. This is
Okay.
sort of like the basic analogy, but the intent-centric world really is you don't only abstract over many different taxis, you abstract over many different taxi providers. So in an intent-centric world, I just say I want to get from A to B under with some security concerns, with some comfort concerns, with some speed, price preferences, right? And I don't actually care if it's an Uber, if it's a local taxi, if it's a tuk-tuk, whatever. If it's a bicycle, if it's a motorbike, I just care that I get from A to B. And so as a result, I never have to interact directly with Uber. I just go, I would like this solved. And maybe there's Uber under the hood. Maybe there's some other local taxi under the hood. This is sort of like you abstract the complexity of compute. Really, like what you're describing is I'm currently in A and I'd like to be in B, given these kind of constraints on how I want to transition. But really, I don't even want to care about how I, like in the kind of, it's almost like you teleport. Like you don't care how you do the compute to get from A to B. You just want to go, I'm in A and I'd like to be in B and just get me there. And I want to think about nothing else. And it's like, this is a very declarative model where you have to, as a user, you have to think about way less things. And as an application developer, your application just becomes way easier to write as a developer here. Because a lot of this complexity is outsourced to solvers effectively that are competing on an open marketplace to give you the best thing.
Right. So it's almost like, so this intent, well, you have to define your intent, what you want to achieve, right? And then how you do it, you let other service providers actually solve the best way to do it for you. And that's what Anoma hopes to achieve with your architecture, right?
Yes. And like here, really, everyone is talking about intents, and no one has any infrastructure for this. Like Anoma is the only and first generalized intent architecture where you kind of truly generalize intents, where you're just defining state changes. Like Anoma doesn't know what a price is, doesn't know what a taxi, it doesn't know what a token is. It just knows I have some state here and I'd like to have some state over here. How do you make this work? So in that sense, Anoma is incredibly, it's not a replacement for existing systems. It is just a thing on top. Like Anoma, for example, doesn't replace Ethereum. Anoma is built on Ethereum. Like Anoma builds an intent machine that sits on top of the compute provided by Ethereum. Long term, this can also be compute provided by Solana or someone else, or like the rollup ecosystem. But like this is fundamentally like Anoma is a new layer of abstraction, a higher level of abstraction to make everyone's life easier. It is not there to replace existing systems. So, and in some other sense, like when you think of something like a Cross or Suave, these are all like specific components within the Anoma architecture. Like it's great what a Cross is doing or what Suave is doing with the private solver DAO. It plugs really well into the Anoma architecture, and it's very good for the overall ecosystem if we have private solver DAOs. But no one is kind of doing this fully generalized intent architecture. Even though I think sort of like give it 2 years and everyone is going to like build their own intent architectures. We saw this with Ethereum. We had Ethereum and then many Ethereum-like systems. And I think we'll see this with Anoma. We'll have Anoma and many Anoma-like systems over time.
So interesting, you just mentioned a term that I think I heard the first time, private solver DAO, right? Can you elaborate more on that?
I mean, in this specific case, it's the ability, solvers can provide different commitments. For example, solvers can provide that they're all running on TEs and they form a network of solvers that all provide like guarantee that they're running in TEs. Solvers can also provide other guarantees. They can provide like latency guarantees or intent. So in Anoma, you can stake to many different roles besides proof of stake. You can stake towards your solvers. You can stake towards your gossip nodes so that they can provide latency guarantees or bandwidth guarantees to you. So there are many more options where what we call this credible service commitments, where different nodes in the ecosystem, different participants in the ecosystem can make credible service commitments, for example, to bandwidth, to compute, to storage. This is really what this comes down to. The other thing here is around composable privacy. And this is really about the idea that, or composable solving and composable privacy. I think there's two important things we should quickly talk about, which is you fundamentally need composable solving. If you do not have composable solving, you will collapse into one solver. And composable solving is about the idea that if there's an intent A for B and some other intent B for C, any solver can collapse this to A to C. This as a new intent that's just A to C. And then sort of at some point later, because maybe that solver doesn't have the C to A, at some point later, a second solver comes along, he happens to have C to A, and then he can collapse this into entire state transition that is settable, right? And this is really fundamentally important because you want to have many different solvers specializing in individual things. And then on the composable privacy side, you want to have users' intents can be issued either fully transparently or in ZK. So like state moves to edge devices like your phone, and then your client decides on what kind of data do I want to reveal. And this is really what in Anoma is called information flow control. It's about you as a user have full flexibility. Do I want to reveal everything? Do I want to reveal something? Do I want to reveal something to only certain parties? And I think these two components is something that no one has even yet sort of thought about, but it's going to be fundamentally important to avoid liquidity fragmentation and security fragmentation. Where it's like if I have an intent that's like wants to trade on Uniswap and you have an intent that wants to trade on CowSwap, there's no reason why these shouldn't be able to be solved in the same model. And this is really what Anoma provides with intent level composability.
Right, I see. So you did talk a lot about a lot of features on Anoma, right? Intent-centric. I think you use the official term like privacy preserving, counterparty discovery, distributed solving, a bit of that. One last thing I think you haven't mentioned, would love to know more, is atomic multi-chain settlement. Can you talk a bit about that?
Yeah, so atomicity is really nice, and I think everyone is sort of currently trying to work on getting atomic inclusion guarantees. This is sort of what the current shared sequencer thinking is about. But with Anoma, you can actually get atomic execution guarantees across many chains. As long, and of course, this is not a restriction of Anoma, this is a restriction of distributed systems. As long as the validators or the operators of every one of the chains involved opt into this, right? So you can have a system where, or you can imagine a world where the validators behind Anoma and the validators behind, I don't know, something like Ethereum main chain, and the validators behind Optimism all decide that they want to offer atomic inclusion guarantees or atomic execution guarantees. And as a result, I can then atomically have state that, and I can make state updates that are atomic to both respective databases or both respective chains. And sort of the trivial example that I always use for why this is very useful. Imagine you want to do a block trade between stock that's traded in London and stock that's traded in New York. If you imagine both of these systems as blockchain databases effectively, what you can do is that I want to do a $100 million block trade, and I'm willing to pay for atomic execution of this $100 million block trade. And so then you pay for it, and it's like not going to be cheap because you're going to pay for the consensus cost of this. But it gives you the ability to atomically sell and buy respectively, and either both of those things happen or none of them happen. And I think this is going to be really important for global consistency, that you have the ability to do this. It's not that everything will want this, right? Like global consensus is very expensive, and so like lots of smaller things, I may be willing to sort of like take the settlement risk that like I'm doing something over here and then over there, it may be reverted. But for like really large transactions or large sort of trades, you may want to have the capability to do atomic cross-chain execution. And this is really like, it's in Anoma, if you're interested, it's called Typhon. There's an entire research paper around this. Actually, there's multiple research papers about this. But it's the consensus that the Anoma team is working on. It's Typhon consensus.
Right, that's cool. And if I understand correctly, when people talk about atomic multi-chain settlement right now, I think they assume that it's under the same shared sequencer, right? But what you're working on, you don't actually have to be on the same sequencer, if I understand correctly.
Yes. So Typhon and Anoma generalized shared sequencing to not require a homogeneous trust model. So you can be under two separate trust models, and you can still do this atomic multi-chain settlement.
Right, that's cool. That's cool. Yeah, so maybe move a bit on your vision a bit. I think one of your vision is really interesting. Homogeneous architecture, heterogeneous security. Can you elaborate a bit more? What does that mean?
Yeah, so this is my personal motivation for why building Anoma. We're heading into this sort of like more multipolar world, and Anoma provides coordination infrastructure that can be as global as possible, but as local as required, right? Like Anoma will work in your local security model. Maybe all of Zug, all of Switzerland loses connectivity with the rest of the world. Users can still use Anoma locally in Switzerland. If connectivity is restored with the rest of the world, they can then be globally interoperable without having to change the applications. This is a really important thing, like that users can roam many different security models and applications can roam on many different security models. And this is the kind of abstraction that the Intent Machine provides us a decentralized operating system or operating system for decentralized applications where I build an application against the Intent Machine, and then I can use this application in many different potential security zones. And this comes from my personal belief that I think we need to build more resilient coordination infrastructure because the world has become more uncertain. And I think this is like one of the best things that blockchains can actually solve, decentralized and like globally resilient coordination infrastructure. And the other thing is like, I am personally not a big believer that there's one best security model. This is like, it seems unlikely that you all want to checkpoint into the same security model. My parents will never trust global Ethereum, no matter how decentralized it may be. They will always trust the local government more, right? And so Anoma's architecture is really about allowing individuals to make choices about what kind of security model that they care about while preserving interoperability between all these different systems and security models.
Right. So homogeneous architecture allows you to have, I would say, like interop, right? And then heterogeneous security allows the developers to actually take the best kind of like most matching security models that fit their use case.
Exactly. Like a very simple example is actually mobile phones here. Like your phone is like I bought my phone, I think in Switzerland, maybe also Germany. I can travel to Thailand with this phone. It will still just work, right? Like even though that phone just has roamed to a different security zone, which is I've left Switzerland and I'm now in Thailand. But all my stuff still works. This is kind of magic. And this is what Anoma enables, that like users can go, I have this one thing that I really like, that I like interacting with. And when I travel to another country, it still just works. So if I travel to another ecosystem, security zone, it just works. That's really like homogeneous architecture, heterogeneous trust, what's all about.
That's a good example. Okay, so next question. I think I want to hear about, say, there are already protocols that are trying to implement intents, right? We hear about CowSwap, we hear about Uniswap X, then there's also like MBV related, Flashbot, Swav. I wonder, like, how do you see all this fits in, especially into like intent-centric architecture and also like Anoma in there?
Yeah, I'm very happy about all these things, I have to say. I think because they're all providing very specific applications, use cases that they want to solve. Like when you think of Anoma, really think of Anoma provides the glue between all these different patchwork approaches. It doesn't try to do specifically what CowSwap does. It tries to, or like it allows CowSwap to coexist with Swav in a unified model, in a unified architecture, so that you do not have to split liquidity between CowSwap and Swav, for example. So in that sense, I'm very excited. More and more people should be building intent-centric applications. And like the cool thing is nowadays, everyone's starting to think about these intent-centric applications. And Anoma is like the only architecture that tries to unify this patchwork of infrastructure. So like everyone wants to build these intent-centric applications, and no one has a good generalized infrastructure to do it on. And this is what Anoma does. Anoma provides a good unified architecture for all these intent-centric applications to actually start working on.
That sounds really cool. I feel like it's kind of like a super app where it's maybe permissionless and open up for people to actually kind of like offer their own services while still being able to interoperate with each other. So that's an interesting future to see. So maybe onto a bit of the use cases. Can you give us like some of the examples of maybe DeFi or even like non-DeFi use cases that you think will emerge from this kind of architecture?
Yeah. So one of the really nice benefits of intents is that intents can be free. As in, if I'm, for example, like one of the easiest to understand examples, it's sadly financial, but it's an obvious example, it's an order book exchange. It is impossible in current architectures to build an actually decentralized order book exchange because every architecture currently requires that all nodes gossip all trades or intents to all other nodes. That is not scalable at all because now intents have to like pay for transaction fees and so on because the consent is critical. In Anoma, intents are free in the sense that they only pay for execution costs when they actually get settled. And then they only pay execution costs to the solver that actually settled them. So as a result, I can build an order book DEX here where I update a price code every half a second or whatever the block tick is. And I only pay for the quotes that actually end up being settled or executed on chain. And the nice thing is also like different nodes in the network can make different choices on like what intents they care about. So for example, maybe a sort of subsection of the network wants to run this order book exchange. That's fine. Then they just run the order book exchange and all the intents here. And the rest of the network only sees the final state updates. It doesn't see all the underlying sort of intent gossip and so on, because maybe the NFT traders don't care about this, right? So, but if a solver is capable computationally of looking at both at the same time, they can find sort of opportunities to provide higher efficiency by settling across both systems. But it's not forced. Like in the worst case, you sort of get an isolated order book exchange, but in the best case, you get a globally liquid, like a multi-dimensional order book exchange that is not specific to specific pairs or assets or NFTs. It just spans the entire thing. So this is the financial application. I think it's probably the single most powerful thing. On the non-financial application, I think something like Gitcoin is a great example, actually. In Gitcoin, everyone currently sends transactions to like indicate what things they want to fund. This is super expensive because I may want to do a micro donation. Maybe there's 100,000 people wanting to do micro donations. And it's kind of stupid that I have to like update this global database, but I have an intention to public goods fund this kind of thing. In Anoma, you can just have a gossip note that goes, well, I'm collecting all these Gitcoin intents, and only if there's an intersection, only if this is actually something specific that we can fund, do I then run the compute to combine all of them and settle this as on Ethereum, where Ethereum just verifies that the state updates are correct, right? So in that sense, you can build incredibly scalable, kind of like the general term is public signal systems, where people can sort of signal what they want, and then other people can come together and fund them. And then the suppliers can come in. I think those are the two sort of simplest examples on things that intents enable. And the big thing to realize is back in the day when Ethereum came out, right? Like we already had the global Bitcoin stock exchange, we had colored coins, and like we had all these ideas of applications that could be built. And we tried building them on Bitcoin, they just ended up being very clunky. And we sort of living in the same world. It's like we know a bunch of applications, but they're kind of clunky or they're super centralized. And Anoma as an architecture fixes pretty much all of these problems, where it's like, rather than having colored coins on Bitcoin, we go to ERC20s, and rather than having like centralized order book exchanges running on top of Ethereum, we can now have fully decentralized order book exchanges, right? It's like there's this very clear progression where every sort of 6 or 7 years, the infrastructure, the architecture has become better. And as a result, like existing applications just like become 10x more usable. And then kind of new things emerge that we had no idea that we were going to need or going to want. And it's very hard, like I could just speculate what kind of cool things will emerge on an architecture like Anoma, because it was very hard to speculate what kind of applications would emerge on Ethereum sort of in the first year, right?
That's true. Yeah, so we have talked about intent-centric applications, talk about how Anoma is tackling that, right? Even we talk about use cases. I wonder what are like the big challenges ahead or the milestones that you have ahead of us. What can we expect to see from Anoma?
Yeah. So the nice thing is in terms of fundamentally designing and speccing out the system, this is all done. The implementation is also progressing really well. I think we're going to have testings by the summer, so next 1 or 2 months. The first Anoma testings will go public. And at that point, you can use sort of all the intent infrastructure, decentralized gossip, distributed solving, and so on. Some of the bigger challenges are still, when you think of Anoma as an operating system and sort of existing systems as virtual machines, as like specific CPUs in like traditional computer sense, making sure that the operating system works really well on specific CPU architectures like Ethereum, like Solana, like Near. I think this is still one of the challenges, and this will sort of still take a couple of months longer to really implement the intent machine operating system on these different execution environments. I think the other big challenge is making this usable. I think over time, over the last couple of years, we've had this expectation that everything has to be super user friendly from day one. And I think this is only the case because we stopped building fundamental innovation. And so I think like making fundamental innovations really good from a UX perspective just takes time. I think, and sort of like the last component is like the cryptography, improving proof of speeds, improve it, like working on FHE. So there's some longer term things here that I think are really important, so that I can enable like an edge device to run a ZK prover, for example, just for succinctness. Yeah, I think those are kind of the challenges. But I'm actually very, I sort of see a multi-year roadmap here of like cool things that need to be built out over the years. But sort of fundamental functionality that will make everyone's life much better right now, I think we're like 2 or 3 months away.
Cool. So we have only maybe one more minute left. Maybe Adrian, do you have any last thoughts, or if people are now excited about Anoma and intent-centric architecture, like, where can they find out more? How can they collaborate? How can they contribute?
Yeah, you can find us on Twitter, twitter.com/Anoma. Anoma is spelled the way you think it should be spelled. It is not complicated, actually. Um, I think if you really want to dive into how Anoma works, especially as an intent machine for Ethereum or as the intent machine for Ethereum, check out the blog post on ETH Research. You can find it on Twitter, but say CW Goes wrote a great ETH Research post that takes like 2 or 3 hours to read that really explains Anoma well in the context of existing systems. And besides that, Anoma.net, you can check out research.anoma.net, which is the entire research forum. There's lots to read. The entire system is also specced out, so you can go to specs.anoma.net. And yeah, then just look out. Like if you're a builder, reach out to us. You can start thinking about building it, and I think in like the next 1 2 months, you can start deploying on testnet.
Cool. So all this sounds very interesting. But we did talk a lot about a lot of things intent-wise, use cases-wise, next steps ahead as well. I think we are running out of time already. So thank you so much for all this information here, Adrian. And hope to see you again next time at Redefine tomorrow.
Of course. Thank you very much for having me.